Boulder! What we're going to do today is we're going to have a look at the generalization of a parabola. That is the merit level of this skill. So here I've got from the marking grid that we will be using. It says that for merit you need to form a valid model that using multiple types of graph that gives a reasonable fit for the path of the marbles through the required barriers. So you've got to get the marbles will be dropping from somewhere, it'll go into a tube somewhere, and you have to use a valid model. Now you're going to have to describe why you chose it, and there is an exemplar for these 2 points in the or on the learning guide. But today we're going to look at calculating a scale factor for that. I could show you period or amplitude, but scale factor is the easiest one to calculate, so that's what we're going to focus on today. So let's say that we have the marbles dropping from this coordinate here, and we want a parabola that guides the marbles to the top center of this tube over here. So to do that, generally what we've been doing so far is we'll make a model. So we'll go y equals, and I don't know what letter your class uses, but let's go a x minus, I'm going to use h for you guys, squared, whoopsies, and then plus the v. So what you've been doing, a lot of people, is you've been just going and using sliders to create a model that does your bidding, right? So maybe you do something like this, and then you probably start messing around a little bit more with the, oh man, I had it so good. So maybe you found that 0.1 is good, but then we need to move it up a little vertically. And maybe then you're like, oh, it's not quite right, 0.08. And you sort of tinker with it a bit, and then you drop the marbles, see if it works, and then that's all good. But we actually need to have a better understanding of the maths than just dragging sliders around. This is a problem-solving skill, and it's good, but we're actually going to have to calculate a scale factor. So what we're going to do first is I'm going to shift over to the whiteboard. Give me 1 second. So what we could do here is we could say, well, I know some facts about parabolas, right? I know that a parabola, if it's y equals a, x minus h squared plus v, well, what I know about that parabola, and sorry about those lights, but I think it's too crap without them. Ah, that'll do. Okay, so what we know is that these things here are actually horizontal shift and vertical shift of a certain part of our parabola. It tells us this point here. Oopsies, that's not on the screen. It tells us this point here, right? And that horizontal and that vertical is all about the vertex of that parabola, right? So the vertex here is going to have h for its horizontal shift and v for its vertical shift. So that is actually the coordinate hv. So we can fill that in straight away. So what we're going to do is we're going to go back to Desmos, and we're going to think, well, where is our vertex actually, where do we want it to be? So I could just get rid of these sliders altogether, and I now know, well, actually the top center of my tube is right here at the coordinate 8.56. So what I can do is I can say, well, that 8.5 is going to be my horizontal shift, and I could write about that as one of my features of my graph, and then 6 is going to be my vertical shift, so I can just whack that in there. So now we only have one thing that we need to mess around with. We've got one unknown now, and that is our scale factor. So what we can do is we can actually use any other coordinate other than the vertex, and we could substitute it into this equation to find our unknown scale factor rather than using a slider to do so. So the coordinate people would tend to use would be this coordinate here, which is 210. But actually our marbles are dropping from 210, so we probably want a coordinate that's a little bit below that. So let's go with something maybe like 29. So we're going to make a new coordinate, 29, and we're going to label this as point to substitute in. Right, so we're going to substitute this point here in, and that's going to be the point 2, 9. I'm just going to whack that up here. Oopsies. Right, so we're going to use 2, 9. So let's go back and do some maths then. So in fact, we can get rid of all this stuff. We know what vertexes do now. So let's rub that out. And in fact, we can just say, well, the vertex is at, and we decided it was at 8.56. So then we can now find out this. Y equals a x minus, and our horizontal is 8.5, and our vertical is 6. So now this is what we have. And you'll notice that we now only have one unknown. These here, you would say that they're unknown, but actually they are variables. You need to have an x and a y inside of your graph so that it has variables so that it can build a picture on the plane that we draw everything on. So these remain as variables. They're not unknowns. This here is our unknown, this a. And what we're going to do is we're going to substitute in a point into y and x to be able to find that a. So we're going to say in our graph, so let's have a look at our graph, that point 2, 9, we are going to substitute that in, and 2 is the x coordinate and 9 is the y coordinate. So we can substitute them in and it will tell us what a needs to be to satisfy that. So let's substitute that in now. So substitute, and what are we substituting? We decided 2, 9. Right? So let's write it out down here and then I'll transfer it over. So 9 is our y coordinate and 2 is our x coordinate. So let's put 9 in for y. So 9 equals a, and then x we now know is 2. 2 minus 8.5 all squared plus 6. Okay, let's move that up and then we will solve it. So I'm going to move it up to here. Where's the maximum amount of space? 9. Oh no, actually we want some space on the left. So when you're doing this in your books, do it on, give a little bit of space on the left to do some calculations. 9 equals a, 2 minus 8.5 all squared plus 6. That's what we're working with. So now in maths, if you've got an equation, which means an equal sign, and it's got one unknown and everything else is known, you can solve to find that. One equation, one unknown, you can find it. So what we have to do is we have to do some reverse engineering. So we're going to try and isolate a. We're going to use SAM-DEB, which is bed mass backwards, and we are going to do opposites. So if it's plus 6, we're going to do minus 6, right? So let's have a go at doing that. So first of all, let's just solve what we can solve. Let's do some, like, whatever maths we can. 9 equals a, and look at this, 2 minus 8.5, well, I can do that in my head. That's negative 6.5. Hopefully my holiday brain is not too wrong here. Now, negative 6.5 squared, I know that negative 6 squared is 36 and 749, but to be honest, I don't really know 6.5 squared. Oh, I could do 13 over 2 squared. No, we're getting carried away here. Let's get a calculator out. Go to the scene. So I've got my calculator. So we're going to go 6.5 squared. And I'm not going to do negative because, to be quite frank, I know that a negative times a negative is a positive. So 42.25. So it's going to be 9 equals a times 42.25 plus 6. Okay, so now what we need to do is just move everything over to the left so that a is by itself. Now, using SAM-DEB, which is bed mass backwards, we can't move the multiplication over. We have to do this first because this is addition. So let's just do the opposite of addition. So I'm going to minus 6 on this side, so I have to minus 6 on this side. So it's going to be 3 equals a times 42.25, and they cancel each other. Now here, What's the opposite of times 42.25? Just divide by 42.25. And if I'm doing that on that side, I do it on this side. 42.25. So 3 divided by 42.25, it's a bit ugly. So let's just do it over here. 3 divided by 42.25, and wow, that is an ugly number. So now we know what A is. A equals 0.071. Oopsies. Dang it, how much of that did I not do on the right seam? My bad, guys. Okay, so let's just have a look at that. So I just did opposites. If I've got plus 6, I minus 6. When I have times 42.25, I just divided by that, and now I end up with the scale factor. So now let's go back here. So now I actually have a value for A that I can just put straight in here. I know that it's 0.071. And notice that that perfectly goes through this coordinate here. So that's all you really need to do to show this merit skill. In your exam or in your internal, you're going to have to do this writing on paper, right? And you want to explain what you've done, explain how you found the vertex. So you're going to have to find the vertex first that you're using, and that's just going to be probably the center of the tube. And then you're going to have to find a coordinate that you want to substitute. Right? So this is my coordinate was that 8.5 and 6, and oh no, sorry, that was my vertex, 8.5 and 6, and then the coordinate I chucked in was 2 and 9, and then that means we can solve for our unknown scale factor. I think that is all. Notice it goes through the point. The marbles would drop here and it would move over to the tube. Maybe one final touch is I'm gonna bound the domain. So I kind of want this to happen between, what numbers? I want it between probably 1 and 8.5. So I'm going to go 1 less than x less than 8.5. And there you go. Oh, it's a little bit ugly. I kind of don't like to know. Let me go 1.9. Yeah, it's a bit better. Beautiful. Now I can get rid of this point, and voila, your marbles will drop and they will roll nicely over here, and then maybe you could put like a circle over here to deflect them to make sure it goes into the tube. I hope that was helpful.